solve problems on queuing model 6 with multi-channel queuing system. First question. At present, a servicing department provides answers through one channel, which on average can deal with 24 enquiries per hour at a cost of $3 per enquiry. Increasingly, the customers are complaining that they have to wait for a long time and the department is considering alternative arrangements. There is either a two-channel system costing $100 per hour and a service rate of $15 per hour in each, or three-channel system costing $125 per hour and service rate of 10 hours in each. Customers arrive at the rate of 20 per hour. Average time a customer is in system WQ is mentioned in question, as well as probability of empty system P0 is also mentioned. You are required to calculate first the average time a customer is in system under present arrangement. Second, the extra charges per enquiry that would need to be made to recover the extra cost of each of the two arrangements proposed. Third, the implied value of customers' time per hour if they agree to pay the extra cost of the two-channel system. This question was asked ICMA London, November 1977.
Let us understand the given data. Present arrangement is having single channel. Then arrival rate lambda is 20 enquiries per hour and service rate mu, that is 24 enquiries per hour. Then the cost is given $3 per enquiry. Now first question, average time customer is in the system. So we have to calculate WS. Now for this WS we have to apply the formula for single channel, because at present single channel is there. So which is equal to 1 divided by mu minus lambda, which is equal to 1 divided by 4, that is 0.25, and unit is hour because lambda and mu are given in hour. So we will convert this into minute by multiplying with 60. So 0.25 into 60, that is equal to 15 minutes. We will move to the second question, extra charges per enquiry. Here the arrival rate lambda is given 20 per hour. That is 20 enquiries are there in 1 hour. Present, the single channel system is in working condition and the data is given for one channel. Cost is $3 per enquiry with service rate mu 24 enquiries per hour. That is in 1 hour 24 enquiries are handled with cost $3 per enquiry. But here arrival rate is also mentioned, that is 20 in 1 hour. So we have to calculate for single channel system what is the cost in 1 hour. So for single channel system, cost in 1 hour is 24 multiplied by 3, that is $72 per hour. Now if we adopt two channel system or three channel system, then what is the cost? So for two channel cost is $100 per hour, for three channels cost is $125 per hour. Now we have to calculate the extra charges. So if we adopt two channel system, then cost is 100 channel and present cost is $72. So here 100 minus 72, that is the extra charge in 1 hour. Now in 1 hour 20 enquiries is the arrival rate, that is 20 enquiry per hour. So for one enquiry, how to calculate the extra charge? That is 100 minus 72 divided by 20, which is equal to $1.40 per enquiry. In the same way, for three channel cost is $125 per hour. So what is the extra charge? So extra charge is 125 minus $72. Now if this is the extra charge in 1 hour and in 1 hour arrival rate is 20. So for one enquiry, how to calculate? that is 125 minus 72 divided by 20, that is $2.65 per enquiry. Now we will move to the third question. We will first calculate the waiting time in system for the two channels. Now here formula is mentioned in the question. Average time customers spend in system, that is WS, formula mentioned as rho k raised to k divided by k factorial 1 minus rho bracket square k mu p0 plus 1 by mu, where k that is equal to number of channels. So here number of channels is equal to 2. So we have to consider here k is equal to 2. Now formula for P0, that is the probability of empty system, that is also mentioned in the question. P0 is equal to k factorial in the bracket 1 minus rho divided by rho k raised to k plus k factorial 1 minus rho in the bracket summation of n is equal to 0 to k minus 1 rho k raised to n by n factorial, bracket complete. Now for two channels, service rate mu is mentioned in the question 15 per hour. K, number of counters, or we can say number of channels, is equal to 2. So rho is equal to, so for multi-channel we will calculate value of rho is equal to lambda divided by k mu, that is equal to 20 divided by 2 into 15, which is equal to 2 by 3. So we have to take the value of rho, that is equal to 2 by 3. So P0 is equal to, so first we will calculate P0, 2 factorial in the bracket 1 minus 2 by 3 divided by 2 by 3 into 2 bracket square plus 2 factorial 1 minus 2 by 3. Now here it is important, we have to take the value from n is equal to 0 to n is equal to 2 minus 1, that is 1. So we have to refer the value n is equal to 0, 1. And we have to take the summation. Now first I will put n is equal to 0. So rho k raised to 0, anything raised to 0, that is 1. So 1 plus, now we will put n is equal to 1. So rho k raised to 1. So rho is 3 by 2 by 3 into 2 raised to 1 divided by 1 factorial, that is 1. Now we will solve this. So if we solve this, then we will get the answer 0.2. Now next is, we will use this P0 in this formula to calculate the waiting time of the in the system, that is WS is equal to, so 2 by 3 into 2 bracket square divided by 2 factorial 1 minus 2 by 3 square k mu, k that is 2 into mu, service rate 15 into P0, that is 0.2 plus 1 by mu, that is 1 by 15. So when we solve this, we will get the answer 0.12. Now if we observe here, service rate or arrival rate is mentioned in hours. So it's a unit is also in hours. Now we will convert it into minute by multiplying with 60, that is equal to 7.2 minutes. For single channel, average time customer spends in system, that is 15 minutes. And for two channels we have calculated customer spends in system 7.2 minutes. So what is the customer's time saved? That is 15 minus 7.2, which is equal to 7.8 minutes. So for this time saving, what is the implied value that we have to calculate? Now arrival rate lambda is 20 per hour, that is lambda is equal to 20 enquiries per hour. Now single channel cost per hour that we have to calculate. Now if we observe the question, $3 for one enquiry is mentioned. So this is the cost, with service rate is given 24 enquiries per hour. Now what is the cost with single channel for 1 hour? So in 1 hour 24 enquiries are completed. So what is the cost? 24 into 3, that is $72. It costs $72 per hour. And for two channel system, cost per hour is mentioned in the question, that is $100 per hour. So this is mentioned in the question. So what is the extra charge per customer? Now we know that arrival rate is 20 enquiries per hour, that is in enquiries are there. So extra charges per customer 100 minus 72 divided by 20, and that is equal to $1.40. So this $1.40 is there because of this time saving 7.8 minutes. But question is that the implied value of customer time per hour. So we have to convert this 7.8 minute into hour, that is 7.8 divided by 60 hour. So for this time, this cost is extra cost, that is 1.40. So implied value 7.8 by 60 into 1.40, that is equal to $10.77, and this is the answer.
Second question. Ships arrive at a port at the rate of 1 in every 4 hours with exponential distribution of inter-arrival times. The time a ship occupies a berth for unloading has exponential distribution with an average of 10 hours. If the average delay of ship waiting for berth is to be kept below 14 hours, how many berths should be provided at the port? This question was asked. Kurukshetra University, BE Mechanical, June 2012.
Let us understand the given data. Arrival time is mentioned as 4 hours, so lambda arrival rate is 1 divided by 4. Service time is also mentioned, that is 10 hours, so service rate mu is equal to 1 divided by service time, that is 1 divided by 10. And we have to find out the number of berths when the waiting time in queue for the ships is less than 14 hours. So here we have condition WQ less than 14 hours, and we have to find out the number of service counters, or we can say number of channels, that is the number of berths. That means we have to find out the value of C. We will first find out the ratio lambda by mu. So lambda by mu, that is equal to 1 by 4 divided by 1 by 10, that is 10 by 4, and which is equal to 5 by 2. So we have to refer this ratio. Now we have one condition, that is for multi-channel queuing system. Lambda by mu C should always less than 1, because in order to avoid the queue explode. So here lambda by mu C we have to keep less than 1. Now we will put the value. So what is the lambda by mu value? That is 5 by 2. So I can write here 5 by 2, and in denominator there is C is less than 1. Now I will transfer C to the right hand side. So therefore 5 by 2 is less than C. So here 5 by 2, that means we can simplify this. 2.5 should be less than C. So we can say that C should be greater than 2.5. So I will write therefore C should be greater than 2.5. So with this arrival rate as well as service rate, we have to keep the C, that is the number of counters, that will be greater than 2.5. So we will take the next value, that is C is equal to 3. Now we will write the formula to calculate the WQ. So we have to calculate this waiting time in queue when C is equal to 3. So when C is equal to 3, we have to first calculate P0. So we will write here formula. So P0 is equal to 1 divided by summation of n is equal to 0 to C minus 1 lambda by mu raised to n by n factorial plus lambda by mu raised to C by C factorial into C mu divided by C mu minus lambda. Now I will take C is equal to 3. Now I will calculate the P0. So I will directly put the value, that is summation of n is equal to 0 to C minus 1, that is 3 minus 1, 2. Lambda by mu. So now we will put the value here. Lambda by mu, that is 5 by 2 raised to n divided by n factorial plus lambda by mu raised to C, that is 5 by 2 raised to 3 divided by 3 factorial into C mu, that is 3 into 1 by 10. So 3 by 10 divided by 3 by 10 minus lambda, that is minus 1 by 4. Now we will solve this. So how to solve this summation, that is which is equal to 1 divided by, we will write here, now we will put n is equal to 0, so anything raised to 0, that is 1, so I will write here 1 plus n is equal to 1, that is 5 by 2 raised to 1 divided by 1 factorial, that is 5 by 2, plus n is equal to 2, that is 5 by 2 bracket square in divided by 2 factorial, that is 2. So if we solve this, so here 25 divided by 4 and here divided by 2 factorial, that is into 2. So we can say that 25 divided by 8. So I will directly write here 25 divided by 8 bracket complete, plus 5 by 2 cube. So we will again simplify this, that is 125 divided by 8 into 3 factorial, that is 6. Here 3 by 10 and then 3 by 10 minus 1 by 4. So we have to simplify this. Now calculated value of P0 is 0.045. So we will put here in the formula of WQ. So formula of WQ is mu into lambda by mu raised to c divided by c minus 1 factorial c mu minus lambda square into P0. So now we will put the value. So what is the value of mu? That is 1 by 10 into 5 by 2 raised to c. So here c is 3. So cube divided by c minus 1, that is 3 minus 1, 2 factorial c mu minus lambda. So again we will find out what is the value of c into mu. So c into mu, that is 3 by 10 minus 1 by 4 bracket square into P0, that is 0.045. Now we will solve this. So here 2 factorial, that means 2 into 1. So when we solve this, we will get the answer 14.06 hours. Now if we observe the required condition, WQ should be less than 14 hours, but it is slightly greater than 14. So we have to consider here the next number, that is C is equal to 4, and we have to solve the question by putting C is equal to 4. So now I will put here C is equal to 4. Now instead of C, if we put here 4, then what are the changes? So C minus 1, that is 4 minus 1, here I have to take 3. Then lambda by mu raised to c, so I have to take here as a 4 into divided by 4 factorial and c mu, that is the 4 by 10, and here also 4 by 10. And now in the same way we have to solve this. So value of P0 is 0.0526. Now we will put the value in this formula. Now here we have to take C is equal to 4, that is mu into lambda by mu raised to 4 divided by C minus 1 factorial, that is 4 minus 1, 3 factorial. C mu, so C value is 4 and mu is 1 by 10. So here 4 by 10 minus lambda, that is 1 by 4 square into P0, that is 0.0526. So when we solve this, we will get the answer 13.7 hours. Now if we observe the condition, WQ should be less than 14 hours and here WQ is less than 14 hours. So we have to take the number of birds, that is equal to 4.